I have to use the microphone. Oh, shoot, microphone, because my voice doesn't carry. So my name is Jennifer Benito. I am a practice consultant with Trace3 in the data intelligence practice, and I am super, super pumped about this topic. So one of the things we've been talking about over the course of the last couple days, and actually Tyler's brought this up in past years, is the saying, all possibilities lie in technology. To me, that does not hold any more true than when we start to talk about artificial intelligence and deep learning. Really, really cool. So let's break that sentence down a little bit. Possibilities. To me, possibilities is artificial intelligence. AI is the possibility of everything. You know, and it has slowly creeped into our lives over the last, I don't know, X amount of years, and we don't even know it, but it lives with us today. So what takes it to execute those possibilities, right? So the second half of that sentence is technology, right? So how does artificial intelligence run? Artificial intelligence executes highly intensive mathematical computations in order to develop the actual analytics behind it. So NVIDIA's GPU executes the parallel processing to accelerate AI and deep learning analytics. And it is the coolest technology ever. And it has, so let's explore a little bit the transformative nature of AI. And we're going to have Andrea D'Souza come up from NVIDIA, and she's going to talk to us for the next, 30, 35 minutes around all the possibilities of artificial intelligence and how we use technology to actually execute. All right, here we go. You're mic'd.
I am a visionary, exploring a universe of data to sharpen our view of the most distant galaxies, and studying black holes to help prove Einstein's theory of gravitational waves. I am a healer, giving doctors the power to turn mountains of data into life-saving breakthroughs, identifying diseases like leukemia from a simple drop of blood, even in our own homes, and finding new ways to bring cures to market faster. I am a protector, keeping our oceans safe from invasive species, and helping our crops flourish while minimizing pesticides. I am a helper, assisting customers in stores and the disabled in their homes. I am a navigator, mapping our world 1 millimeter at a time, and making even the largest self-driving vehicles safer for the long haul. I am a creator, learning to paint from the masters and applying their styles to create original works of art. I am a teacher, analyzing 500,000 player moves every game to identify strengths and weaknesses, and a learner, discovering new strategies from complex games. I am even the composer of the music you're hearing. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Amazing video from our creative department. And the wonderful part about doing a tech talk the week after our GTC conference is you get to leverage the content. So how many of you were actually out at GTC last week? That's great, just a handful. If you haven't, it was my first Tech Talk. The irony of this entire conversation that I'm about to have with you is 7 years ago, I made a career decision to run away from the CIO track. And it took me 7 years to get off that track. And I've landed in this amazing, amazing, wonderful place where we truly are building the future. So let's get started here. I hope that video got you jazzed up. I hope it got you excited about what truly is the next $1 trillion opportunity. That may actually be an underestimate. And the reason I believe it could be an underestimate is we are experiencing the fourth industrial revolution. We are witnessing an epic change in the way we live, work, and communicate. And NVIDIA has been instrumental in the AI movement. I'd like to change your mind through this conversation that we are no longer a hardware company. In fact, we probably never were. Our CEO is probably one of the most brilliant strategists I've ever run into. And to tie that together, why we are here with Trace 3, we cannot keep up with the demand for our capabilities, our hardware, our software platforms. And as Tyler alluded to, I'm here to change the conversation and ask each and every one of you to come with us on this journey as we invade new territory and strike a balance between change and growth. AI is impacting everything we do. How will you be part of that change? So this all got started with CUDA, a programming language. If you're the type that's easily distracted and wants to get on LinkedIn right now, go ahead, do the CUDA search. You'll end up with approximately 500,000 results. It's officially a skill that people are looking for. But more importantly, as I mentioned, the number of GPU developers has increased 11-fold in the last 5 years. And if you did happen to be at our GTC Technology Conference last week, it isn't just a technology conference. I pushed some of the executives from healthcare to attend, and I was amazed at the thank you notes that I got from the C-suite, the number of requests for follow-up visits. Our GPU technology, our AI computing platform, our message is resonating with the world. If you have a chance, make sure you attend next year. So for those of you who may not know, just a quick anchor point, what is this thing that we call artificial intelligence? It's actually been around, for those of us who have been around, for a really long time. And we actually originally failed at it the first time around because we didn't have the compute power that we needed. So when we think artificial intelligence, we think of it in the most broadest way possible. Speech to voice, voice to text. We're using it daily in everything that we do. Machine learning is a subset of that. I come from the field of computational biology. I'm originally a scientist by training and actually made that journey into tech by accidentally tinkering with the computer and stumbling upon a discovery that made it to phase 2 in the clinic. Some executives quickly transitioned me into IT. Okay. Machine learning is a cornerstone of what we do with computational biology. It's a subset of the broader field of AI. And then deep learning. And what deep learning really is the utilization of those neural networks, where instead of writing large amount of code, you're actually feeding label data to a network, and the network learns. Once you've got a trained algorithm, you then set the stage for inference. Did I hit the wrong button? I told you I'd do that. Okay, so when do you use deep learning? I think the answer to this question is really simple. You use deep learning when you have enough data, your data needs to have labels, and you use deep learning when accuracy matters. So machine learning typically, to get the improvements that you need, doesn't matter what field, whether it's fraud detection or medical imaging, the rate of progression and accuracy rate takes much longer if you don't do deep learning. So if you look at the difference of those curves, one of the key questions you have to ask yourself is, if I go back into my organization, can I find labeled data and sufficient quantity of labeled data coupled with the right technology in order to do deep learning? The recipe is really, really simple. And if there's one thing you take away from this talk, is you need three things. You need data, you need technology, you need our GPUs, and you need algorithms. So, making things simple takes time. And the reason we are here today and able to actually demystify what's happened is a consequence of a large amount of innovation that has happened across the ecosystem. So Andreessen Horowitz calls this the Cambrian moment. If you notice, I'm wearing red today. Our roots at NVIDIA are actually in computer vision, in graphics. And we stay honest to those roots. We're always investing in technology, in innovation, so you can see all the beautiful color in the world. Fei-Fei Li, an amazing researcher, had the insight in 2010 to create a database of images. And then she sponsored a contest. Alex Kravetsky won that contest, starting to get to that level of accuracy in terms of detecting cats. Innovation upon innovation in methods research, in underlying GPU technology, to get us to the point where recently the FDA approved an algorithm for detecting blood flow in the heart, disease detection, and potentially diagnosis. A computer beating AlphaGo. Who would have thought that would even be possible? And the one I think, as an introvert, truly, truly resonates with me, especially as Tyler shared the story of his son, Jack. We're getting to the point where you can take text and convert it to speech and voice with Deep Voice. If you have a minute, spend some time on that website. We're going to get to the point where introverts like me can type up what we want to say, and I don't have to come here. So, what's NVIDIA done that's so brilliant? What is our strategy? So yes, it all starts out with amazing hardware, our deep learning SDK. But much more importantly than that, what we've done is there's a tremendous amount of innovation that we've fueled through our research programs in Vail, encouraging the academic community to continue to build out these frameworks and advance the state of the art in algorithms. We've then taken all of those algorithms and actually packaged them in our appliances so that all of us that have data scientists are not spending their time compiling algorithms, but actually doing the data science work that we need done. We want to spend less time working. We want to spend more time doing things that truly, truly matter. Curing disease, preventing fraud, making more money, whatever matters to you. That's the value proposition for our entire hardware and software stack. So what you see in those big green boxes, probably the most important green boxes you'll see here today, are all of the programs that we have in place to fuel the innovation in the ecosystem. I talked about in Vail, amazing amount of research happening in deep learning and AI behind the scenes through NVIDIA Research. And two that are very, very near and dear to my heart, the Inception program, which fuels all of the innovation that happens in the startup community. We've heard multiple talks today. We've heard some pitches from various startup companies. Startups measure where disruption is happening. And last but not least, healthcare and the enterprise. So I'm here to actually share with you that when you look across the ecosystem, our Inception program has enrolled 1,300 startups. Keeps growing and growing and growing. I can't keep up. Most of us at NVIDIA can't keep up. But the reason there's such a tremendous amount of innovation happening here is actually in 2016, over $5 billion was invested in startups. That's over a 900% increase in the last 4 years. So big numbers, because it doesn't matter where you are, everybody wants to see the change happening. So when does this change actually start to go mainstream? When did deep learning go mainstream? So I like to stop a minute. I've talked about the innovation that was happening in 2010, 2013 with speech, images, recommendation engines. What were you doing in 2013? Anybody remember? Were you using Netflix? Were you using iTunes? Remember when the only real recommendation you got out of iTunes was, oh, you bought a Michael Bublé album? Here, buy another one, right? Or maybe you were recovering from a medical illness and you were wondering, why did my doctor miss that diagnosis? That's where I was at actually in 2013 when I was working at the Broad Institute. Our organization was going through a huge transformation, and a lot of us were impacted. The only team that they retained on staff and moved into different parts of the organization was the applied data science team that had the vision to build. That team has now grown into a 100-person data science organization. Those were the signals that suggested that deep learning was going mainstream. So today, if I use Spotfire, it's actually understanding through deep learning the underlying music and acoustics that I care about. So it knows, yes, she does like Mick Jagger, but she likes Norah Jones. And more importantly, you'll periodically find her listening to Latin music or French music or opera. That's the power of deep learning. Periscope, video. We're constantly videotaping everything from cells in animals to find novel pathways for drugs, to videos that other companies like Dextro can use to analyze the impact of our brand names and recognition. Huge, huge, huge change. So today, in the enterprise, here are the 4 things that I think every single enterprise is actively having a conversation around. Voice, across the enterprise, security. The wonderful part of being the last speaker is I don't have to go through this conversation in great detail. We've seen a tremendous amount of talks around security and the use of machine learning behind the scenes. Finance, and last but not least, healthcare. And anticipating that I'd have a largely male audience, I've tried to pick an example that's relevant to all of you in the audience. So let's get started. Call centers. If I just did a quick poll, how many of you in your enterprise organizations have a call center? How many of you have multiple call centers? So some of the organizations that I'm working with, big, large, global organizations, one of them actually said they think they have 23 different call centers. So one of the places where we're seeing disruption in the call center, or I would actually say effective utilization of AI, is with these call centers. So I have a Dutch niece and nephew. Routinely, every other year, I buy them tickets because I don't have any kids of my own to come spend a month with me in the summer. This is one of those summers. I log on and have the IM chat with KLM, the Dutch airline. In that conversation, I find out real quickly that they're using an AI agent behind the scenes. How do I know? I know because they pause for a bit, and then their answers are so meaningful and relevant. I find myself Googling DL and KLM. Guess what? Behind the scenes, they're using Digital Genius, one of the startups in our Inception programs. Bear in mind, I've only been at NVIDIA 9 months. I'm drinking from a fire hose. I'm learning like crazy. Google's one of my secret weapons. So call centers, effective change. What happens once you've collected all that data, text data, voice data? We've built that knowledge base. Then you've got things like DeepGram, where you can actually analyze all of that data to generate actionable insights. So imagine if you're Kaiser and you want to figure out why the number of patients for back pain is increasing in your ER or urgent care centers. Perhaps the answer to that question resides in that treasure trove of data where they've called your call centers and failed to manage their back pain, and then out of sheer desperation, they end up in a more high-cost environment. And then last but not least, GridSpace. Amazing, amazing innovation. And the example that resonated the most, especially since last week was earnings weeks left, right, and center, is they're actually taking the voice recordings from the earning call, transcribing them, because you can sometimes skim text much, much faster. Sentiment analysis on top of that. So huge, huge change with voice across the enterprise. Next place, security. I'm going to go real fast. This is a great example coming out of Accenture. They have a security lab, and what they wanted to do was increase the productivity and output of their analysts working in that security lab. So they're actually using a combination of CUDA and machine learning. I always get this number wrong, 200 to 300 million reports per day, and it's all about increasing the productivity and output of those analysts. Big, big change, huge, huge opportunity, and you see this across the enterprise. Early detection is key, whether you're talking about security or the other place is in finance. So we are actually seeing an amazing amount of what I call true innovation in finance. Most of us remember PayPal from the early days, years ago, so fraud detection is really critical to them. About a third of our transactions happen online. Quantitative analysis, algorithmic trading. I'll share a little bit of what I can share with you. And then imagine a future where we could actually prevent some of the catastrophic financial things that happened years and years ago that led to some of the fundamental changes in the way we work. So why do I love PayPal? I love PayPal because they've actually gone this journey where they originally started out writing software to figure out what was a fraud, loads and loads of software. They then transitioned to using machine learning, and then more recently to deep learning. And as I mentioned, they've seen their accuracy increase over time. PayPal apparently processes about, $9 million worth of transactions in 1 second. So this is really, really critical to their business from a reputation management perspective, from a top line and a bottom line perspective. So as a consequence of this transition to deep learning, they've managed to reduce fraud claims by 50% and actual fraud by 10%. So back to a very, very relevant example to many of us as our worlds have changed. I call this one a day in the life of Andrea. So I'm an evangelist. I travel the world evangelizing the use of AI in a meaningful way. So I was speaking in, let me see if I can remember, England at the Sanger Center. My nephew, purely out of guilt, I'm saying yes, wants to know, can he buy an online video game with that same credit card that I'm planning to use in England? And I say yes. His mom doesn't know, my sister. She'll probably know if she watches the video. And my sister-in-law is booking the tickets for my niece and nephew to come to America in the summer. So that's what's happening, all on this one credit card. Remember, 7 years ago, if you went through 3 zip codes in a day and a half period, by the time you were on an empty tank of gas, you wouldn't be able to use that one and only credit card that you had. What happens in this case? I get a quick little text message. Are these transactions real? Reply, Y for yes, N for no. I say Y, I'm okay. Deep learning and our DGX architecture stack behind the scenes, along with a mobile app. This is the future of finance. I'd love to tell you more about where deep learning and AI is being used in the enterprise and financial services, but the reality is that this combination of data, technology, and neural networks is a competitive weapon. And so where we are in this journey is very few companies are actually willing to reveal what they're actually doing. What I can say is the startups are more willing to talk. So here's a great example of another entrepreneur, Gaurav. I don't know Gaurav. I can't wait to meet Gaurav. He built his skill set, won a tremendous number of awards while at a New York-based hedge fund tower. 8 or 10 years into it, the time Malcolm Gladwell claims is what you need to build true expertise, he decides he wants to make a difference. And he wants to make a difference by making finance fair. So he spins off not one, but two companies. QPlum is the second one, where he's managed to generate a tremendous amount of profits by using real-time quantitative deep learning strategies to bring the power of deep learning to the ordinary investor. So how does this matter? It matters in a very ordinary way. Used to work at Amgen. A couple weeks ago, I think it was 2 months ago now, I find my large institutional investment management firm buying more Amgen stock at $180 a share. And I wake up and I get the automated message, quickly shoot off a message, and I say, can you shed some light on this? And he gives me the usual answer, it's a long-term play, it's a portfolio play. I'm thinking, why would you do that with all the headwinds coming? Why would you do that if I've already got a position? Check the stock price. It's trading closer to 160 right now. So what I love about this is if I was to forecast the future, this is an example of a company that could truly make a difference in ordinary people's lives, and more importantly, encourage the financial industry to disrupt itself. We've seen a tremendous amount of change with the consumerization of healthcare, and I think there's going to be a real opportunity for the financial industry to follow. It's actually rare that you see healthcare following finance. It typically tends to go the other way around. So at NVIDIA, one of the things that we've done wonderfully over the last decade or so is have an amazing presence in medical imaging. For those of you who've ever had an MRI scan with the GE Revolution scanner, the odds are really high that you've been exposed to 80% less radiation as a consequence of the way in which our GPUs have been used to accelerate the delivery. We continue to build upon that practice. So I think I mentioned Arteris got FDA clearance for their blood flow detection algorithms. So that's the first example. We know of a whole portfolio of companies that are actively in clinical trials. So tremendous amount of disruption across what we call the disease spectrum. Detection, diagnosis, and treatment of disease. In the pharmaceutical industry, sequence call variants. So basically, we all have 2 billion base pairs in our genome. Just as Moore's law has come to an end for computing, we're seeing an equivalent amount of innovation or disruption with genetics. And so most of us can get genotyped now for $3,000, maybe $5,000. And that actually sets the stage for building large, well-annotated databases so you could figure out what's the probability that I'm going to get diabetes and what type of diabetes am I going to get versus what type of osteoporosis or arthritis, or if you're in one of those unfortunate categories, likely to get cancer. So, talking about cancer. We made a lot of progress, but what a lot of people don't know is when we talk about cancer and survival, we're typically estimating what is the probability that you're going to live 5 years or longer. And that's something that we'd like to fundamentally change. We estimate by 2030, there'll be about 22 million new cases of cancer, and a larger percentage of us will die, 13 million, and I think that's partially because we have an aging population. As I mentioned, we're turning a page in our journey with artificial intelligence. There's 3 things that have come together: data, technology, and the algorithms. So what we wanted to actually share with you is an example that's relevant to all of the men here in the audience: prostate cancer. I'm guessing, and please correct me, I'm single, so I never really know these things for sure, most of you don't enjoy that exam where you've got to go and get that prostate exam. I'm also encouraging you to definitely get that exam because the estimates of who may get prostate cancer are quite high. In 2012, I believe the number was as high as 1.1 million new cases. If you do get cancer across the world, one of the leading places that you go to is Memorial Sloan Kettering Cancer Center in New York City. So they are happy, active users of our GPU technology because what they've been doing over the last decade through the leadership of Thomas Fuchs, who started his career as a rocket scientist at JPL, is they've been amalgamating one of the largest data sets for prostate cancer. And they're getting to the point where they've trained deep learning models using advanced neural nets, convolution neural nets, GANs, to set the stage for clinical grade pathology. Imagine if you didn't actually have to get that prostate cancer test as routinely as you're now required to do so. So that's the win in it for each of us from a healthcare perspective. I'd like to leave you with that one simple recipe. Hoping all of you love to cook. You need three things. You need data, and you need a certain amount of data. For those of you that are deep learning experts, the CIFAR-10 data set, on that slide there you can see that's one prostate cancer tissue biopsy slide, and then you can see the CIFAR-10 entire data set. So the volume of data that you get out of biopsies is much, 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 much higher. What that inherently means is, wonderful, you've got great data to train. Paige, the company that they're spinning off of from MSKCC, has created an interface that enables the pathologist to actually give them the labels that they need to annotate the data, that then sets the stage with the algorithms and NVIDIA compute to build out the right platform. So AI's here, it's here to stay. Think about where you're using it, how you're using it. We're seeing a convergence of high throughput, performance, efficiency, effectiveness. Anybody and anybody you ask typically will respond and say more than 90% believe it's impacting their work. But I think more importantly, more than 90% believe that they're seeing great results and they want to continue to experiment and experiment. I genuinely believe this all started with Moneyball. So years ago, when I was running a large group on that CIO track, my team wanted to come over to my new house in Calabasas, California. So I went ahead finally and gave in, let them all come over. And one of them, who I still keep in touch with, he looked at my bookshelf. I'm an introvert. I love to read. And he says, everything on here makes sense except for that. And he points to Moneyball. I'm like, oh my God, I love that book. I grew up with the A's. My first date was at Giants Park or whatever it was back then. And I said, help me understand. Why don't you think I'd like that book? And we never really answered that question. But sports analytics, data-driven analytics, a data-driven culture, I think is what genuinely started this movement. Because in the absence of that data, we couldn't truly get to this moment in time. So, the other true indicator we have that this has gone mainstream is SAP. A bunch of our colleagues from NVIDIA are actually out at the SAP conference, and they've all been texting or sharing images of how SAP truly believes that AI is being adopted. Text analytics, sentiment analytics, and the one that I think will resonate with anybody, brand recognition. So I'll end with this. It was an amazing conference last week. I guess I'm rethinking my decision with respect to being part of a tech world. Finally have this moment in time. Our new Volta architecture was introduced. We've also introduced our platform for inference. Once you've trained all of your algorithms, the true big win is, can you infer at scale? as you see more and more of those algorithms come to market, I think the way in which we interact with technology is going to change. So you're going to see inference in your home, in your car, in the trains, in the buses, already using it for airplanes, and more importantly, in places that really matter, like money and finance. I often joke, I love the fact that this conference had so many jokes. If you go to a healthcare conference, you're not likely to see as many of those. That my last car will be a robot. So one of the other things we announced was Isaac. And I envision that when I'm old and in, that nursing home, if you've got the longevity that comes with the genes I have, bring me my morning coffee exactly the way I like it, and my meds. I'm like anybody else, I'm going to need some. Collect all my data, beam it up to my doctor, and readjust when my next visit should be. So that truly, truly is, from my perspective, the future. I understand from our CEO that we're going to start small, and in our new building, Isaac is going to bring us salads. So thank you for this amazing opportunity. And if I could, I'd like to invite my other NVIDIA colleagues up here for a couple questions. I think I need it. Oh. I want to quickly introduce. No question.
Presupposes there are questions.
Yeah, go ahead.
All right.
Thanks, Adam Miller from Capital Group. Could you talk about Google's, I forget what, it's like a Tensor chip. It's their new hardware that combines a couple things. How does that compare to the NVIDIA GPU, or how will those two work together or against each other?
Sure. So the new TPU, they've announced it, and they've sort of announced that they're going to make it available. They haven't put a lot of technical details out yet. Certainly the prior generation of that TPU processor is really aimed at inference, and it was developed at Google about 2 GPU generations ago. And so 2 generations of GPU ago, we were still necessary for training. Even they recognized they didn't want to try and build a parallel accelerator for that. But Google has one of the few gigantic inference workloads around, just at cloud scale. And they looked at our product as it existed then and said, maybe we want to try our hand at building an ASIC for this, just for the power efficiency. About the time they launched that ASIC, because it takes a long time, even if you have Google resources, to design a new ASIC and launch it, we've gotten a generation and a half of GPUs out, and we're roughly on a par on the energy efficiency scale, ballpark at least. I think this new generation is probably, again, they had to have started that at a different point in the past. They're still using GPUs for training. They still use GPUs for inference in some places. I think it'll be interesting. It's, in the broader picture, this is a great time to be a customer with a workload that you want to run efficiently, because the options you have to architect a solution that's going to make sense for your project, whatever it may be, right? Storage, compute, networking, distribution, software. You have so many options, and you can do it the easy way. You could do it the way you've always done it, and that will probably work. And one of your competitors is going to think about the problem a little longer. And if it's really important to your business, they're going to take it and they're going to tune each piece of it, and they're going to be 10 times more efficient. And that's what you see our customers and people like Google trying to do, is be that at that leading edge of efficiency.
As a deep learning evangelist, when we saw what happened when we mapped the genome,
Yep.
and some of the chaos that happened there, where people got patents on genomes and now people can't get drugs, because they're so overpriced? Does it scare you a little bit that there might be patents on algorithms that will save lives? Because it scared the shit out of me when I just heard that story, and there is some carnage of mapping the genome. And when I saw that blood flow thing, I could easily see patents on algorithms that will control the price and economics of how people can get health care based on. Anyway, have you thought about that?
So it doesn't scare me, and the reason it doesn't scare me is I genuinely think that you've got enough checks and balances in the system in a competitive marketplace to have that all kind of even out over time. I think the more important thing is, I think 4% of us experience some sort of medical misdiagnosis, right? So I fall into the category, and in 2013 I experienced an epic failure in the healthcare system. And I genuinely believe if we had better tools and technology for the doctors, I probably would have had 3 years of less misery personally, 3 years of lost income. So I fall into that category of somebody that's definitely willing to pay. Anybody else got a perspective?
We have time for one more. All right, Tim. I got you. You mentioned deficiencies, and I was wondering if you have, and obviously this is maybe super secret stuff, so don't say anything that you have to kill me with afterwards, is actually looking more toward, is supposedly electronic chips usually going into photonics, which obviously much more efficient, less heat. Have you guys, in the architectures in the future, are you guys looking at photonic chips?
I would say it's safe to assume that NVIDIA research is looking at those technologies. I think one of the things that makes, if you look at the history of, I'm going to digress a little bit. If you look at the history of compute acceleration to date, there are a number of companies which had fantastic products for one release and then died. Or maybe they got 2 or 3 releases out and then they died. You have to have some economies of scale. And as our CEO pointed out, one of the reasons that we can impact in healthcare, in finance, in computer gaming, in graphics, we can be all those places because there's synergies there and there's an economy of scale. And so I think, photonics is an area that I think everyone is researching, but I think there has to be it can't just be a research project. It's got to become something that you can go out and get fabbed for you, and it's not there yet.
Thank you very much.